actually work? Hello, hello. If you showed up, realize that I left my help that mod. I am a stream. Hey, Carter. I just don't click on that. Yeah, okay, okay. That's the plan. And what else do I need to do? Yeah, I got sure. Tried to see me at school today. I got super wrecked by my vaccine again. I have had a wonderful last 24 hours. Hey, Rose. What's up? Oh, Kruzich sent me a question that you were working on. Or that you did because Mackenzie did it, I think, and the answer was wrong. And I turns out I agreed with you, as did Kruzich. So that was pretty cool. I'm gonna re-reel this so much I forgot. Yeah, yeah. Probably not the only one. All right. What else? Can't focus at all. 3 hours of skills all day. Not lead to smart brain. Oh, that was not the right button. Raw, that's the right button. Is it going to be the normal 130 points? Yes, it is. Kennedy, are you okay? I'm leaning towards a hard no on that, but yeah, I'm here, so that's pretty good. Hopefully I'll be okay tomorrow. I have written the test. It is done. Not too many typos, but brain is mush. Yeah, there was something I was gonna do. Oh well. Well, I have the review up. The review, probably have done some of these questions at some point. Maybe they were test questions. But I really wanted to focus on kind of the last page of this test because the free response on this are what is really important. Dang, it's 13.265% of our grade. Yeah, so I'm leaning towards something that maybe you might be okay with. Think about putting the free response on second semester's grade and then making it retakeable when I get back. Because it's like insanely good review for the AP test, so we get to kind of double dip useful. I don't know if that's helpful. Kind of curious what the read is of the folks in the class. And hey, Anna, I've been flaming your brother all year, so you're probably very happy with that. Your brother's pretty great. I very much enjoy him. Yes, please. Yeah, okay. Got at least 1+ on the second semester grade for the free response. I think that's fine. Especially since I don't know when I'm going to get my hands on grading these free response sections. Yeah, we'll see. I've also heard you're flaming me through him. Oh yeah, for sure. You're a fun reactions person. Yeah, that's a very good to do that option. Sweet. Sounds good. That is less work for me now when I am not well, and more work for me later when I'm hopefully more well. So that's good. I'm down with that. So, I did want to start off with the notes question, actually, because I started the notes in, if you're in second period, we haven't started the free response notes, I think, at all. And then in fourth period, we started the first one. And good evening to you as well, sir. So, yeah, I'm just going to start here. If you have questions on the review, feel free to put them in chat. I'll head over that way after doing this. Yeah, I'm just going to begin here. So, this is the second question that is of maybe the type that we're going to see on the tests. This one is a little less similar. The first one, I would say, is very similar to what is going to be on the final, this question. Maybe not D. I can tell you that I generally have like a kind of a grab bag question, and it's probably not going to be one that's exactly like this, but these other parts are like, I'd expect these 100% on the test. So I'm going to jump into this question first. This is a derivative graph. All of these are going to work out that way. They're either going to be like this first question where the integral of f is s. So f is the derivative. It's kind of helpful to think about this as s prime of x for the sake of doing this question. And it's very similar to this type where it says it's a graph of f prime, and then you're answering questions based on that stuff. So for -5 to 5, say where there's a relative maximum, that's just where we go from increasing to decreasing. So that would be right here at -3 and right here at 4. From -5 to 5, say where we have inflection points, those are maxes or mins. So that's at -4, at -1, and at 2. All of those for that one. So I guess I should be writing these answers here. -3 and 4, and -4, -1, and 2. And then find all the, oh, by the way, if you're curious where this is, I should have led with that. Those of you in fourth period probably know, but this is in the free response notes. So these are meant to give you an idea of the kind of questions that are coming. So I would say this second question is very similar to note 16, which is the mean value theorem and evaluating derivative graphs. And also, two of these parts are likely to be two of the parts on the test, just a smorgasbord of reading derivative graph sort of questions. I can also guarantee, I know I'm fragmented here, that I'm going to have a question like this first one here. This is like a really good grab bag. So I'll probably go and demo one of those on the review, because there's a similar one to this on the review. The question on the review is actually pretty hard. Find all the intervals on which f is concave up. That's where the graph of f prime is increasing. So that would be from -5 to -4. And from -1 to 1. And actually, so this is a bit of a conundrum here. So at this point, since we have like a cusp in our derivative, the second derivative is actually undefined at that point since it jumps. So it's actually not decreasing. So we actually do have to split up this interval. So if you're curious about that, we do have to say from -2 to 1 and from 1 to that. So you do have to split that up because this point has an undefined second derivative because it jumps there. I'm pretty sure the one on the review is the exact same as the first one. Is it? Yeah. If I was on my A game, that wouldn't have happened. Okay, find the absolute minimum on the closed interval. This is where we get really integral thinking, because the absolute minimum on the interval -5 to 5 is the point at which I've gone to the left the most, or gone negative for the longest period of time. So area under the curve is how I find the value of f. And I start off by going up by some amount here, and then I go down, and then I go up, and then I go down just a baby bit. So if I'm thinking about this, I'm starting at a value, I'm going up a little, I'm going down a ton, then I'm going up some, and then I'm going down less. So right here at 1 is where my minimum would happen, just based on analysis of the graph. So x equals 1 would be where the minimum happens. -2 to 1 doesn't work. Oh, -1 to 1? Well, I looked at the graph. Say that, lol. Thank you. -1 to 1 is correct there. I read the y value instead of the x value. Why you shouldn't get your booster right before you take your final, if you have huge reactions like me to all of your COVID vaccines. Not that either? No? Am I still misreading it? Graph is going up from -1 to 1. It has to have a positive slope too. Oh, and also has positive slope. Wow, I'm an absolute potato. You are correct. Get rid of this -1 to 1 garbage. I didn't read the question. -5 to -4 and 1 to 2. Thank you so much. Class, I am totally with you. I didn't read well. I have not gotten up much from the couch today. Oh, man. That's the derivative graph. Yes, this is the derivative graph. So where it has, since it needs to have positive slope and be concave up, it can't be this -1 to 1. I just read the concave up. If it had been just concave up, it would have been from -1 to 1 and from 1 to 2. But because it needs also a positive slope, we actually get rid of all the stuff down below. And we only take from 1 to 2 here, and from -5 to -4. Can you go over the free response of the review sheet? Yeah. Are there captions on this? I think all YouTube videos you could turn on closed captioning. And I think it's pretty cringe usually, because I talk weird, and so it does not... Is this the exact question? Oh, man. Mr. Kennedy, you could have just written different questions, written different whatever. Let's jump into doing this. If you were there in fourth period, we did do this question, but I'm going to go through this, especially since this first question is very much going to be on the free response on our tests. So, let S be the function given by this integral. For each of s of 4, s prime of 6, and s double prime of 1, find the value or state that it does not exist. The first thing you do is, since we're trying to find s of 4, s is the integral of f, so it's the area under the curve from 0, which is our lower bound, to 4. So you just need to find the area of this, like, ended triangle here. So there were a few different ways to go about doing this. I think the way I chose on the answer key, which I have posted, sorry I didn't send out an email about that, looks something like this. Did I goof it up on the answer key too? Like, maybe? Hopefully not. I probably did. I was really wrecked earlier. I'll do it right here. 5 times 3, 15. 5 times 3 divided by 2, 7.5. And lastly, 5 times 1 divided by 2, 2.5. Yeah, I totally got this wrong on the answer key because I found like s of 6. It's kind of questionable. Yeah. Yeah, I've been a train wreck today. 10 plus 15 is 25. Cool, that's s of 4. S prime of 6, that's just the value of f, which is 0. That part's chillin'. And s double prime of 1 is the slope of the graph at 1, and this thing has a slope of 5. Yes, I'm going to go over all the parts in these. Find the x values of the relative extrema. There's literally only one here. It's where the derivative graph goes through 0, which is at 6. So x equals 6, is a maximum because it goes from positive to negative. So that was it for that one. It was a relative max. Next one, find the average value from 5 to 8. So from 5 to 8, this area here is 2.5. And this area here is 2 times negative 5 divided by 2, which is a negative 5. I did clarify in class the find the average value of the function above. Sorry, I should have totally clarified this. I'm remembering. I meant of S on all of these, so I had my 4th period repair all these. So these are like of S. I'll find the relative x values of. Whoops. Nope, I didn't want to cross that out. When I said graph above, this was. Oh, what the heck is that? Wild. Was supposed to be an eraser. Instead of the graph above, it was supposed to be S on these. I apologize for that. So I clarified that, and I was going to clarify that tomorrow. I'm really hoping I can be there tomorrow. Super duper. But if I feel like now, I am a absolute. I can't right now. Anyways, find the average value of S on the interval. So since S is the integral of f, I would add together these areas, get negative 2.5, and divide by 3. So I apologize, this question was insanely poorly worded. Negative 2.5 over 3. Let's say you assumed it was of the graph above and said where there's a maximum. You literally just read the x equals 2 and x equals 7, and the 2 is a max and the 7 is a min. But this type of question is not going to show up like this. It's going to show up like the first way, which is how the question should have been written. So if you answered this way, that's correct, but not how the question will look on the test. All right, the last one, literally all you do is you find the slope of each of these line segments, and you can check the answer key I posted because it's just a weird type of question. We probably won't have that type of question. No tests? I have written it, so if I can get it copied, you could still have the test. So I'm hoping to be there. I'm really hoping I feel better than I do right now. All right, next one. So again, you can look at this one, but I can all but guarantee you that this type of question, D, won't be showing up in your test. It's going to be a little bit more of the question 4 variety. So wait, why is the relative max at x equals 6? If we're talking about S, the relative maximum of S is the antiderivative of f. Since this is a derivative graph, I would look at where it goes through 0. Where the derivative goes through 0 is where I have maxes or mins, so it'd be at x equals 6. So that's why if it had been talking about S, it would have been that. So again, my people who are in 4th period, I clarified that, and sorry for putting it on the review. Okay, second question's really, really good. So this is an AP question. So you can, just so you know, when questions are like real AP questions, you can totally Google this. If you Google this, the graph of the function f shows above consists of 3 line segments. You can find the question really quick. It's like 2006 B or something. And you can find the solution for any of those sorts of questions pretty nicely. So the graph above is referring to S. It was insanely poorly worded. This was an old test question that I worded really poorly, so I had to accept both of these answers on that test. Your one should be better worded. I will double check after this to make sure it is better worded. And this next one is very consistently worded. So this time, g of x is the integral from -4 to some value of f of t dt. And the first thing you're doing is finding g of -1, which is literally just the integral from -4 to -1, which is the area of this trapezoid. Which you could do the area of the trapezoid, or you could just do rectangle, triangle. What I did. So it's 3 long and 1 tall, so this is negative 1.5, it's negative because it's below the axis, and 3 by 1 triangle. Then we have a 3 by 2 box, so that has an area of 6, and so this would, negative 6, because it's below the axis. This would have an area of negative 7.5, which would be the value of g of negative 1. What's the answer to part C on number 1? It was negative 2.5 over 3. Sorry about my bad handwriting. I'll rewrite it. It was the area from negative 5 to 8 of the graph divided by the width of the graph. And it was supposed to be of S. I apologize again for the bad wording. Anyways, g prime of negative 1. This one's nice and easy. It's just f. G prime is just f. So it's f of negative 1. And that's just negative 2. And last one, g double prime is the slope at negative 1. And this is a cusp. So the slope would be undefined there. And so it does not exist. Says state that it does not exist. We'll put d in. Next one, for the function g defined on part A, find the x-coordinate of each point of inflection. So points of inflections are maxes and mins. You might notice a lot of overlap between these questions. Very similar to the one I did on the B one. We had a question like this. So we're just looking for maxes and mins in this graph. There's one here at 1. That's it. This is not a max or a min because it is increasing on both sides. So it never switches from increasing to decreasing. So my inflection point is only at x1. And then it switches things up. Instead of g of x, we now have h of x, and x is now the bottom bound. This is where things get a little bit weird. So next it says, where does h equal 0? So we're starting at 3. And if we start here at 3, well, first, if I plug 3 in, I get a 0 width interval. So x equals 3 is the first value. Like super obvious for where our integral equals 0. So if it's a cusp, it's undefined. Yes. Because it's the slope of the slope graph is undefined there. Cusp. Okay, so x equals 3 is the obvious one, 0 width interval. Then, if I cut off right here, this up triangle and this down triangle are exactly the same. So x equals 1 would be another spot where my integral from here to here would be 0. And then this up triangle and this down triangle are also the same. So actually, negative 1 also would be a spot where my integral equals 0. So that one's kind of an interesting question. As long as you see that there's like significant symmetry between these up and down segments of these triangles, you can get those. Then we go like negative over here so that we never get back to 0. If we're at 0 at negative 1, if we go away from 0, which is what this stuff is doing, we're not going to end up back at 0. We need an equal part above the axis after that. And then the last one is a bit of a trip to think about. Can you explain C? Yeah, so all I'm looking at is where this integral equals 0. And the first way is to plug in 3 and get a 0 width interval. So if I go from 3 to 3 here, no width, it's going to have an integral of 0. The second way is that the down triangle and the up triangle here have exactly the same area. So if I integrate from 3 to 1, those parts cancel, and I end up at 0 again. Since the change in the areas denote the change in h. And then this up triangle, this down triangle are also the same. And since I'm 0 here at 1, these two parts will annihilate each other as I integrate this direction, and I'll get back to 0. So these parts are canceling out the up and down triangle parts here. Hopefully that cleared up C. My eraser not working. Very confused by that. Look at the oh, because it's on a picture. What? Okay, I can get rid of that, and now the picture's less busy. Okay, all you need to do for B is inflection points are where the second derivative changes sign. So it's where the derivative of the derivative changes sign. And since f is a derivative graph of G, then where this thing changes slope, which is only here at 1, is where I have an inflection point. If this had turned around over here, if this graph had gone like this at -1, then I would have had another inflection point right here at -1. But I don't have that, so only here at 1 is the only spot where my derivative graph turns around. All right, the last one is the most confusing of them, I would say. For this function h, find all the intervals on which h is decreasing. So this is where things get weird, because h is the integral from x to 3 of showing up, right? I'm not too low. Yeah. X to 3 of f of t. So what I did, the way I like to think about this is I wanted to swap these bounds. I kind of wanted the x on top, so like x is in my destination and 3 is on my bottom. So I swapped the bounds and put a negative. So I said this equals, and I swapped the bounds to be 3 and x of f of t, f of t, and now that I know this is negative, what I've learned is that I'm flipping the parts. So actually, my negative areas, because I'm going backwards, are where I'm going up. And my positive areas is actually where I'm going down. And since I only have one spot where f is positive, which is from 0 to 2, that's the only interval on which h is decreasing. So again, a bit of a trippy question there, because I had to apply my properties of integrals to be like, yo, I want my x to be in my destination. If I think about going that way from 3 to the left, then I get negative accumulations are going up, and positive accumulations are going down. Do we actually have to explain our reasoning on these? Yes. So you'd have to explain that, yo, because I'm going backwards, this would have to be negative. Although, if you didn't have your reasoning, you probably wouldn't get this right anyways. I think this is an acceptable way to explain your reasoning. Yeah. I can show you. You can also Google this question and see other people describe it. But anyways, if I was, where else did it say explain your reasoning? So for x equals 1, I believe on my key said f has a max or min, or has a max at x equals 1, which is an inflection point in S. S has inflection points. So that would be how you justify. It's basically just describing why you know it's the right answer. Oh yeah. It doesn't let me write in the gray part. So you just have to show your work. Essentially, if you are able to describe it in a coherent manner, that's really what matters. So inflection points, look at where the derivative has max or mins. Max or mins in, like, say, G. It would be where this thing had gone through 0 and 2. So I would have actually said 0 is a minimum from negative to positive, and 2 is a maximum from positive to negative. So that could have been asked in this question, and wasn't, but very much something that could be on the question on final. So the reasoning doesn't need to be words, it could just be the math. Absolutely, yes. If you look at AP answers, when it says justify your reasoning, sometimes justify your reasoning is like a table with values. And if you have that table with values, it works. And we have both Rachel H's, so I don't know which one is which. All right. What is chapter 4, question 2? Because it looks gross. Okay, cool. I get to go somewhere else. Hopefully you're somewhat sated on this free response. if you're just showing up, I'm probably going to put that on semester 2's grade so you have a chance to retake it. So hopefully that's cool. My energy's kind of holding up too, so I might actually make it 45 here. Maybe an hour, who knows? Okay, so question 14. Okay, so what this is missing is an equal sign. So if you're confused by this, if that equal sign's there, there's definitely an answer. So it's saying f is continuous on an interval. That just means the integral works. If it's not continuous, the integral doesn't work. Then there exists a value c such that there's a value in between a and b where, and now we have to look at these. So first things first, we're integrating. So it's got to be one of our integral rules. So it's not difference quotient stuff. This is derivative stuff. This is not integral stuff. Also, this one involves the derivative, but we're literally integrating f, which means we'd be going to big F, so we're not going anywhere near f prime. So get out. F of b minus f of a? No. If I integrated to big F, it would be big F of b minus big F of a. That could have been an answer if I had like stated that big F was the integral of little f. I have posted an answer key for this, yeah. And so that only leaves us with one eligible one here. And this is exactly average value. If you divide both sides by b minus a, you get the integral from a to b of f of x divided by b minus a equals f of c. And this is exactly average value. That's what this question was going for, was trying to get you to do average value. Yeah. Up, finish writing the f of x. So yeah, by process of elimination, you could get rid of those if you got rid of all the derivative ones and got rid of the ones that definitely aren't accurate. It left you with only one that could be accurate. Can you do part 1, 2, and 3? There are first part of that question. Part 1, 2, and 3. Is the Frq retakeable? That's my plan. My plan is semester 2 grade, yes, retakeable, but the retake won't happen until we're preparing for the AP test, because it's insanely good review for the AP test. Also, I'm not sure when those grades will go in, because I am going to be horizontal for a very long period of time. So will there be a gross one like this on the test? If there was an equal there, that's very much a type of question that could be on the test. I would tell you that questions like this are more likely to have integral properties. So think the quiz we just took in class, the one you know, like the addition property of integrals, the notes 22 or like that, is going to be more there are going to be more questions like that of this type. So definitely know your integral rules, know which ones are rules, and know which ones aren't rules. I can tell you that is very, very helpful for this test. Kennedy, what paragraph do you envision yourself as? Would I be right now? 1 over x. Yeah, that's my paragraph. All right, so only 100 points is going into semester 1. That's my plan. How is it not B? B is the difference quotient. This is average rate of change. This would be what the derivative equals if we're approximating. It's actually not even that. It's like nowhere near the integral. So that's why it couldn't be B. Oh, you answered that question, but not my first one. Sorry. Why is the equation on the bottom true? This is average value, just straight up. If you check out average value in your notes, you'll see exactly this equation. So this was a way to test average value. All right, question, okay. Chapter 4, question 3. I can definitely go there because it's right here. All right, this is an evil question because it's asking for the average rate of change of y with respect to x. So average rate of change is exactly b here. We want to use this equation from up here. But we want to use this on y. And we have dy dx. So first thing I got to do is integrate this equation. If I integrate dy dx, I get y. If I integrate x, I get x squared over 2 plus c. Then I'm ready to go. I do y2 minus y1, plugging into this y equation that I had to integrate to get. And I get 16 over 2, which is 8, plus e minus 1 plugged in, which is 1/2, plus c. All over b minus a, which is 4 minus 1. And so this ends up, the c's just cancel. We get 8 minus 1/2 is 7.5 over 3, which is 2.5. 7.5 over 3, which is 5. So a bit of a tricky question, but not mathematically hard. Like, that's a baby integral. And then you had to know to use the average rate of change equation, which is the slope equation, by plugging in 4 and 1 and dividing by 4 minus. Hopefully that makes sense. All right, question 2, 3. Sorry, chapter 2, question 3. Ugh. All right, these rate at which something else is increasing, you just take the derivative of both of the things. So the derivative of sine of 2x is 2 sine x cosine x. If you don't remember why that is, it's chain rule. So if we put the squared on the outside, you pull down the 2, multiply it by sine of x, and then multiply by the derivative of the inside. And then that equals, that's what is generally means in these equations here. K times the rate at which x is increasing, which is 1. That's the derivative of x. Rate means derivative in these questions. And then all you do is plug in pi over 4. And so you get 2 times root 2 over 2 times root 2 over 2 equals k. K times 1 is just k. And that's 2 times 1/2 equals k, which is 1. And so that was that question. If you're in class tomorrow, can I ask you then? If I'm there, definitely ask me. I am really hoping to feel better soon. I am not there yet. All right. Chapter 6, question 4. Okay, so the way I do absolute value questions that are linear like this is I literally just draw x minus 3, which looks like, yeah. And then I mark off 1 and 6, and then I find the area of the triangles. That's the easiest way to do that. Otherwise, you can integrate from 1 to 3 of, it's the negative part, so negative x plus 3. You just multiply the inside of the absolute value by a negative 1. And that's this part. You can see it has a y-intercept of 3 and has a negative 1 slope, so you can even get it from the graph. And then on the other side, we just integrate from 3 to 6 of x minus 3. So this is how we deal with absolute values that are jankier, is we'd have to split to 2 equations if it had like a squared in it. But if it doesn't, you're just finding the area of triangles and adding them together. So either of these methods, what do you get this way? You get 1/2 2 times 2, which is 2, and 1/2 3 times 3, which is 4.5. So this is 6.5 or 13 over 2. Add those parts together. What are the chances you'll be at school tomorrow? I wish I knew that answer. I'm hoping to be there, especially since it's a Wednesday. If I can cover by 10, then hopefully I can be there. Since I have the test written, all I have to do is copy it. So I should be chilling on that front. So I'm really, really hoping I'm there tomorrow. Anyways, Charlotte's question. All right, can you do part 1, questions 2 and 3? Sure. So part 1, questions 2 and 3. So first one asks, where is the following function continuous? So you plug in 1, natural log of 1, chillin', that's 0. If you don't remember what log looks like, it looks like this. And it goes through 1 comma 0, and it's continuous there, so chillin'. E to the 1, also chillin'. Exponential graphs have no problems. They just, they're continuous everywhere. That's a terrible exponential graph. Make it better. There we go. Other one is trash. Bye-bye. And then last one, if you plug 1 in here, you get natural log of... Oh, wait a second. This was wrong on the key. Crap. Kennedy, you're a disaster. E minus 1. Natural log of E minus 1 is actually like here on the natural log graph, which is actually chillin'. So all 3 of these should have been continuous. He definitely wrong on that one, because I remember thinking that this was x minus 1. If it had been natural log of x minus 1, it would have been not continuous. If you plug 1 in, you get natural log of 0. That would have been bad. But it wasn't that, so it should actually be E on that. Maybe I can fix this key and upload it. All right. Let's see, the other question. 3. Wait, part 1, questions 2 and 3. No 3, part 1. Chapter 1, question 2, and chapter 3, question 1. Did I get another one wrong? Maybe. Okay, so at what x value does f of x attain a relative maximum if it's this function? So what I did was distribute x to the 6 minus 3x to the 4th. And if you take the derivative of this, you get 6x to the 5th minus 12x cubed. If you factor out a 6x cubed, you get 6x cubed times x squared minus 1. So we have 3 critical points, -1, 0, and 1. And since it's an up graph, I know it looks like this. Okay, I did a little bit of cheating here. Because these are all odd, I know there's no like bouncy root, no inflection point and or saddle point. So I was a little bit lazy there. I could check on either side of these and make sure. And sure enough, it does at values. So negative times positive, negative. Hey, look, it looks like a graph. Negative times negative is positive. Positive times negative is negative. And 2 plugged in gives me positive times positive, which means we're changing at all of them. So the maximum only exists at 0. So that's which that happens. No, it's x squared minus 2, Kennedy. Oh, goodness gracious. Mr. Kennedy. Disaster. Oh, Lord. Kumbaya. Alright, Did I goof that up? Oh, my goodness. So at what x value does this thing attain a relative maximum? Oh, so it doesn't actually change anything. Moral of the story. These become root 2, and it's still 0 that's our maximum. So that's pretty cool. I goofed that up, like, horribly with my math. But the answer's the same. Chillin'. Alright, feels good. Ugh. Yeah, I really gotta re-upload this answer key when I fix all these. It's really hard to do. And have the change. Alright, how many points of inflection does the graph of blah have? 3, 4. Hopefully I didn't skip anybody's question. Maybe I did. I think I did 2, 3. Okay, cool. 3, 4. So for inflection points, we take 2 derivatives. So 12x to the 5th minus 45x to the 4th plus 40x cubed. And then we go again. 60x to the 4th minus 180 x cubed. Oh, goodness gracious. Writing. 80 x cubed plus 120 x squared. Cool. 2 derivatives found. That's how we find inflection points, is going to the second derivative. Then I factored out a 60 and an x squared, which makes things a whole heck of a lot nicer. We get x squared minus 3x plus 2. And this is a double root. There's not going to be an inflection point here. That's like one of the cheaty shortcuts you can do once you understand the patterns in these. But I am going to have stuff at these values. X minus 2, x minus 1 is what this factors to. And these values should yield points of inflection. So the answer here was 2 for both of those. And you could have tested on either side in the second derivative to ensure that what I said about the even roots was correct. And since this 60x squared is always positive, all you had to do is plug into x minus 2 and x minus 1. So negative times negative is positive. So that's concave up. If you plug 0.5 in, negative times negative is positive, so concave up again. If you plug in 1.5, the first parenthesis is negative, the second one's positive, so that's concave down. And then 3 plugged in makes them both positive. So only at 1 and 2 did it change. So 2 points of inflection is pass. I skipped Carter. Uh-oh. Sorry. Problem 6, chapter 4. Then I'll go to 3-7. Oh, yeah, this question. Okay, so convert to an integral. Okay, the first crap is just the integral sign, that stuff. Then get options. So on the answer key, I did the integral from 3 to 7 because the width is 4 and the values start at 3. I'll do it the other way here. You could do the integral from 0 to 4 of 3 plus x dx. That would also work. This integral will yield the exact same answer as one. So either this, or if you haven't seen my other answer, this is the same as the integral from 3 to 7, since the x values, oh my goodness, my handwriting. I need to change my mouse since 7 of x dx. Either of these work, they give you exactly the same answer. I think, yeah. So yeah. When you plug in, so you integrate to like x squared over 2, and then you plug in 7 and 3. It's 49 over 2 minus 9 over 2, which is just 40 over 2, or 20. That was actually kind of nice, that one. But you had to realize that width over n is one of your pieces. That's always your dx. And then width over n times I can be your x. That's doing it the first way. But since we have the shift here and it only applies to the x part, I can also call it the integral from 3 to 7 of x dx, which was probably a little bit of an easier integral. So they both work. They both yield the same answer. 3-7, and then I'll come back to 4-5 here. Okay, 3-7 is a bit of a trip. Okay, so for 3-7, it says it has a point of inflection at x equals 1. The negative 6 doesn't matter for this part. So first thing I'd do is I'd take 2 derivatives of this, 3x squared plus 2ax. A reminder that a and b are constants, so they're just like treating them like a number. Plus b. And then if you take a second derivative, you get 6x plus 2a. And I know my point of inflection happens at x equals 1, so I know the second derivative equals 0 if I plug in 1 for x. So all you get is 0 equals 6 plus 2a, and this is really easy to solve for a equals -3. Okay, once you have this, we know a, so we can use that to figure out b. And the other piece of information I know is that the y value at x equals 1 is -6. So I can plug in -6 for y, and 1 for x, and -3 for a, like meow. And you just solve this for b. So we get you actually get -6 plus b equals -6, so b was just 0 in this. So that was the play. We actually didn't use the first derivative for anything to solve this question, which made it interesting. So yeah, that's a good one. How did we get -3? If you solve 0 equals 6 plus 2a, which is what you get when you plug x equals 1 in, and that the second derivative equals 0. Points of inflection happen when the second derivative equals 0. So I plugged in 0 for the second derivative. This was first derivative. This was second derivative. I plugged in 0 for it, and then I plugged in 1 for x, and I solved for a. So you can just like subtract 6 from both sides and divide by 2 to get a. So is a equal -3? Yes. And then you use that just back in the original equation, plugging in 1 for x and -6 for y, and you get b pretty easily. We actually don't use the derivative for anything to solve this question. Interesting. Yeah, a bit of a thinker question. Okay, where am I going next? It was 4 or 5, I think. What is the average value of 3x minus x squared in the first quadrant? So all you need to know was roughly what this graph looks like. You factor out an x. You can get that the zeros happen at 0 and at 3, and it's an upside down parabola, so it looks something like this. And so the stuff in the first quadrant is just this up part that happens between 0 and 3. And that's why I integrated from 0 to 3 for the function, and then divided by 3. And that's it. And it's a pretty easy function to integrate, get to the answer. Hopefully that sates people on that one. Starting to fade a little bit here. Whew. Look through this. Amy's weird. We got that. Can you explain how you knew the integral was 0 to 3? Yeah, it was literally from graphing it. So I factor out an x out of 3x minus x squared, and I got that the zeros of the graph were 0 and 3. And if I know it's an upside down parabola with zeros at 0 and at 3, I know it has to look like this. So I know the part in the first quadrant is the part that's in between that 0 and 3. So that's an way. Basically, graphing the function is how I knew it was the. Was that really a surprise though? No, it was not. Question 4.3. Okay, so I did cover 4.3 earlier. This question, you had to integrate the derivative equation here, which was a pretty easy integral. And then you had to do y2 minus y1 over x2 minus x1. That was how to do that question. You just had to plug in 1 and 4 into this integral equation, which is what I did right here, and divide by 4 minus 1. So it was just straight up average rate of change. No explicative suggestive language. Hopefully I haven't said any expletive. This is L'Hopital's rule. Like, that's definitely the way you should solve this. So chapter 1's a little disingenuous for this. If you take the derivative of the top, you get sine of theta. And if you take the derivative of the bottom, you get 2 sine theta cosine theta. And if you cancel out the cosine thetas, or sine, oops, you get 4 sine theta cosine theta. Oopsies. I always forget to like pull the 2 out and multiply it by the 2. You get 4 sine theta cosine theta on the bottom, because we pull the power down, multiply it out front, and then chain rule out the cosine. Once you cancel out the sines, you get 1 over 4 cosine theta, and you plug in 0. 1 over 4 cosine of 0 is just 1/4. So just a little bit of L'Hopital's rule. If you don't remember L'Hopital's rule, it's taking the derivative of the top and bottom independently of each other and then reevaluating the limit. That only works because this was 0 over 0 straight up right away. And I'm not sure if there's a great other way to solve it out. Oh, there is. If you know sine squared plus cosine squared equals 1, you could also do it that way. So you could solve for sine squared in this equation, and you could plug it in on the bottom, and then it's 1 minus cosine squared, and then you could cancel out a 1 minus cosine on top and bottom. You could get the same answer that way. That sounds harder. So I would do L'Hopital's. Alright. Hopefully that sated people's questions. Just be aware that the test is graded like normal. Definitely focus on questions you know how to do right, especially if you're somebody who tends to struggle on these tests. Every question you get right pulls you away from that guessing average, which is the only thing I give Fs to. So, yeah. That's what's up there. 2-2. You can check out my answer key. I'm too tired. I'm sorry. I don't know if I can do any more today. How many seagulls would it take to be in your room for you to be suspicious? I think 1. 1. I haven't seen a seagull in a while. They don't come out to Maple Valley. Let's see here. Could you go over how many problems there are in each section of the multiple choice? A lot more, no calculator. Imagine like 13 no calculator-ish, and like 5 calculator? I think that's roughly. Isn't half a seagull more sus than 1? Well, maybe I'm hungry. I don't know. Do people eat seagulls? Probably. Certainly, like, if I was a seal, I would. I'm not. So, I don't know. If the half was the head and the feet, and I don't know if I'm about that life. I can't get into chicken feet and stuff. Man's about to eat a seagull. It's probably not very healthy, huh? There's a lot of microplastics in the ocean, so we eat fish. I don't know. If I eat one, can I get an A on the next test? Probably not. You probably won't feel very good. Probably will not get an A. You probably feel like I did today. I will eat a seagull for extra. Don't do that. Also, one thing I can shout out before I leave. There will be U substitution on the test, but all of the U substitutions are really obvious. They are exactly the derivatives. So no evil U substitutions. Those should be easy questions if you got your practice in for U sub. So hopefully you can rock those. Which U substitution is what we were doing the last few days. So I did put those on, but yeah. Hopefully I will feel better. That'd be dope. Anyways, adios, amigos.